Welcome back. This is an Aleks training video on predicting the single bonded molecular compounds formed by two elements. Metals with nonmetals form ionic bonds. So if you have a metal that turns into a positive cation and a nonmetal that turns into an anion, negative, they stick together like socks in the dryer. They do not use the subscripts di and tri and penta. And they do not form molecular bonds. They form ionic bonds. If you have nonmetals with nonmetals, they will form molecular bonds. They share electrons. They don't steal them. They don't become ions. And they share their valence electrons. When you have them, their names have to have the Greek prefixes. All right, so we're going to look for nonmetals with nonmetals, and if so, they're going to form a molecular compound. Write down the chemical formula of that molecular compound and its name. Okay, so the first one I have here is magnesium and fluorine. Magnesium is in group 2, that's a metal. Fluorine is in group 7, that's a nonmetal. So it does not form a pair that will form a molecular compound, so therefore you do not write a chemical formula or a name. So the first one, there's nothing. Nitrogen and iodine are both nonmetals, so they will form a molecular compound. So nitrogen is in group 5, and iodine is in group 7, but that only works whenever you have ions. To think of it as positives and negatives, it doesn't work anymore. So you can't think of them in terms of negatives or positives because they're sharing. So you have to now think, okay, what would be the center atom? Is a nitrogen and 2 iodines going to attach to a third iodine? Or would it be more logical to put the nitrogen in the middle and have 3 iodines hold on to the nitrogen? Do you see that's a better plan? So I'm going to write nitrogen, and then I'm going to write its valence electrons with the Lewis dot structures. So I have 1, 2, 3, 4, 5. It's in the 5th column. It has 5 valence electrons. So here on the right is a lone pair, and then at the north, west, and south are single electrons that can bond to something else. Okay, so obviously there's 3 here, and there's 3 iodines. Well, I guess it's not obvious. Why would there be 3? Okay, so let's look. Let's say you put an iodine here. Iodine is in group 7. So what is its Lewis dot structures? Okay, so it would be 1, 2, 3, 4, 5, 6, 7. Do you see? By doing this, I'm going to have a bonding pair. I'm going to have a bonding pair between the iodine and the nitrogen. And I'm going to give the iodine 8. It only had 7, and now I'm going to give it 8. So I'm going to do this 3 times because I have 3 arms for the nitrogen. So I'm going to do it over here. 1, 2, 3, 4, 5, 6, 7. And I'm going to do it at the top. 1, 2, 3, 4, 5, 6, 7. So what is its chemical formula? Ni3. And what's its name? Well, whenever there's 1 at the first, you don't say mononitrogen. You're just going to say nitrogen. So it'll be nitrogen. But the third one, or the 3 iodines, you are going to have to say tri. And then iodide, because remember IDE endings for the second. So nitrogen triiodide. Let's do hydrogen and bromine. Well, hydrogen only has 1 electron. It needs 2. So you're going to have a bond. So So there'll only be one bond since there's hydrogen on that side. Let's see what bromine's going to do. Bromine is in group 7, so there's 7 of them. 1, 2, 3, 4, 5, 6, 7. So I only need one hydrogen and one bromine because here is a bonding pair. So it's the 2 counting for the hydrogen, and it's 2 counting for the bromine. And so I have 1, 2, 3, 4, 5, 6, 7, 8. So bromine has an octet, hydrogen has an octet. And so this will be the answer. So this is going to also form a pair, a molecular compound, because hydrogen is a nonmetal, even though it's in group 1. Bromine is a nonmetal, so it's a nonmetal with nonmetal. That's molecular. Its chemical formula is HBr, and you would name it hydrogen bromide. I think this may be a tricky one for you. I'll try to help you in class all I can. Just do it again and again and again, and you'll eventually get great at it.